Jai Hind everyone. My name is Anushka Tyagi. I'm assistant professor at IT department. Today I will be discussing about the networks model. So as we know the layers concept in our daily life. We use layers concept in our daily life. For an example, if we are sending some letter from one friend to another, so there is a proper process for sending a letter. If there will be no process, the process will be complex then. So as you can see in this example, there is a task. We are having the task between sending a letter to a friend. So there we have one sender and one receiver. So as you can see in this, there is a sender. Then first of all, the first step for the process is the letter is written and put in the envelope and dropped in the mailbox. Then the process continues. Then and the second steps came, the letter carried from the mailbox to the post office. Then like this, all the process continues by step. Then at last the letter got delivered to the carrier, to the post office. Then there is some transmission medium between them. Like what is the medium? The source to destination. Like it can travel by we are sending our parcel by air, by road, anything. So then the letter goes from post office. The letter then goes to the post office. Then the carrier received it. Then the from the post office it go in this step the sorry in this step the letter goes from post office to the mailbox of the sender. In this example, there is some task involved in which we are sending a letter. So first of all, we have two people, sender and receiver. First of all, sender follows some process, some process to send a letter to a receiver. As you can see in this diagram, there is a sender. The letter is written and put it in the envelope, and it is dropped in the mailbox. Then the letter is carried by the mailbox to the post office. And then the letter is delivered to the carrier. Now and you can see in last, the parcel is carried from source to destination. It can be by air, by road, anything. Okay. Then the letter is delivered from carrier to the post office. Then the post office sends the letter to the mailbox of the receiver, and at last the receiver receives the letter, open the envelope and read it. So here, as you can see in this example, each and everything are going from one step to another step. It becomes a whole process from sender to receiver. Sender performing some steps, then there is a transmission medium, then receiver then to the for the receiver some steps are going followed. So the OSI model is established in 1947 by International Standard Organization. The ISO standards cover all the aspects of network communication. Okay, and all the aspects of network communication, and this is known as the Open System Interconnection Model, OSI model. It was first introduced in late 1970s. So how ISO propose or develop some standards. So what are these standards? These are the standards these are some standards which develop a common standards between all the type of manufacturers, sender, receiver. So there is no differentiation between the senders or receiver or the type of data we are sending. They come on the common ground for all the standards and for all the data sent for going from sender to a receiver. So how ISO follows the structure process? First of all, there is a proposal stage. There is a need for a standard to identify and get proposed. Then in preparation stage, experts draft the standard, like how it's gonna be working and all. Then committee stage, member discuss and some changes and some refine the draft, like convert some changes, like adding some changes to the draft. Now, inquiry stage, a draft was shared with other other members in the countries for the feedback. Like they take the feedback, then they changes according to the feedback. Then there is an approval stage. The voting will be done. Then if it is voted on, then it will get approved. The publication stage, the standards is published and implemented globally. So these standards help us to communicate easily with different manufacturer. Like we can easily communicate with a phone to a laptop, laptop to a PC to a telephone, anything. We can easily communicate with each other with the help of these. One of the most well-known ISO standard in networking is open system interconnection model, which we are using on the daily basis. So it helps us to standardize communication between different computing systems. Like we can easily communicate between computer and laptop, laptop to telephone, telephone to phone, anything we can communicate. The ISO rule in OSI model, it is created by ISO. OSI model is created by ISO, and you do not get confused. So ISO is the organization and OSI is the model of that organization. So don't get confused between ISO, OSI model name. So the OSI model contains 7 layers: physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. This helps different network devices like computers, routers, switches to communicate seamlessly. Here are the 7 layers: application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. So as you can see the interaction between the layers in the OSI model. So as you can see, there is a device 1 and device B. So there is in between you, as you can see, there is an intermediate node. Okay. So the data is traveling from device A to device B. So as you can see, a device A has a OSI model for 7, 6, 5, 4, 3, 2, 1, all the layers in backward count. Then there is a physical communication, there is a physical transmission of data. Then for the sender, for the device B, for the sender, we have the data, we have the link layers in the numbering for 1, 2, 3, 4, 5, 6, 7. So the data is traveling for 7 first OSI model to the backward, like 7, 6, 5, 4, 3, 2, 1. Then getting transferred from physical transmission, and then it will going from to the layer forwardly 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now the exchange using an OSI model. So as you can see in this diagram, there is a data in on all stages of the data, like on D7, D6. This is the data D6, D5, D4, D2, D1. Now as you can see in this, there are some headings. There are some headings like H1, H2, H3, H4, H5, and there is some tail like H2, T2. Like as you can see in this diagram, these are some properties which we are adding on each of the layers. Like that helps to communicate easily with the other layer of the sender, receiver, whatever it is. So as you can see, and on each layer we are adding some information like H7, H6, H5, H4. So these are some information or key points which we are adding from one layer. Then it can easily goes to the sender. It can easily goes to the receiver, and it can communicate it easily. So first of all, we have the physical layer. What physical layer is the layer which is directly connected to the transmission medium for both, like in sender side, on the receiver side. Okay, as you can see in it receives the data from data link layer, and in sender side and receiver side, it is sending data to the data link layer of receiver. The physical layer is responsible for the movements of individual bits from one hop to the next. So it is responsible for the now in this we will use some different terms like hops, nodes, everything. So that just don't get confused. This will all contain about the data. All the meaning of these terms are like kind of data, but we are using some types of words, some types of terms to easily distinguish between layer to layer. Okay, so this is the summary for all these layers. We will be discussing about them in detail in next lectures. So So in physical layer, it interferes between the medium. It defines the characteristics and the interface between the devices and the transmission medium. Okay. It also defines the type of transmission medium, like how transmission we are using. Representation of bits, like how zeros are one changed into signal, or how signals are changed to zeros and one. Okay, so data rate, the transmission data rate bit sent each second is also defined by physical layer, like how the data is sending to the receiver, how the sender is sending a data to the receiver, like how, on which data rate he is sending. Then line configuration is concerned, this layer is concerned with the connection device to the media, like point to point configuration and multi-point configuration. Point to point configuration, direct configuration. Multi-point configuration, like it will connect it to the many other connections. Like physical topology, it also defines how the devices are connected to make a network. Okay, so in this we have the transmission modes, like we have transmission modes which are simplex, half duplex and full duplex. Now the second layer is data link layer. As you can see in this layer, the data is converted into frames. So as I have told already, like we are using some terms like nodes, nodes, hops, frames, so that it can be easily, that we can easily distinguish between the layers and layers. Okay, so in this we are using data, we are using the term frame for the data. Like as you can see, there is a H2 and T2, like head and tail we are adding in the data link layer. Data link layer is responsible for moving frames from one hop to the next, one node to the next. All the frames are the data. The data link layer, in the data link layer, what are the frames? What is the process? What is framing process? So in data link layer, it divides the stream of bits and received from the network layer and divided into manageable data units. Like it will convert big data units to small data units, which can be called frames. The physical addressing, if the frames are distributed to the different system of the network, the data link adds header and a tail to a frame, so it can easily be checked out by the receiver end. So here we have the flow control and error control also, and we also have the access control. These all types of controls are the error checkers we are checking in this layer. Okay, now as you can see, there is a hop to hop delivery node. So nodes, which are nodes, the A, B, E, F, A, B, C, D are the nodes. These are the nodes. These are the connection devices from where our data is passing. So these are the nodes. They are the hops. So we have hop to hop delivery. We have node to node delivery. So as you can see, we have to search for the best path for the receiver end to receive the data. So as you can see in this diagram, we are switching for the second option, like in which we have the devices A, B, E, F. So we are sending a data from A to B to E to F. Okay, so now next we have network layer. It will be receiving a data from a transport layer of a sender and sending data to a data link layer. A data network layer is responsible for the delivery of individual packets from source host to destination host. Okay, logical addressing and routing. The independent networks or links are connected to create a large network. The connecting devices such as router, switch, and the packets to their final destination. One of the function of network layer is to provide mechanism. Okay, logical addressing, the physical addressing implemented by data link layer handle the addresses problem. If a packet passes the network boundary, so we need some type of source and destination address. So we add the source and destination address to the head and tail of the data link layer. Now we have source to destination delivery. So as you can see, we have we are in network layer, we are setting a proper source to destination. We are not switching the paths. We are not switching the paths. If we are receiving a data, so we have to set a source and we have to set a destination. So in this, as we have adding source and destination address, so same diagram as a data link layer, but we have a proper source and destination delivery, like proper process. Now in transport layer, we convert that data into segments. As we have discussed earlier, we are using new terms for the data, for with the help of that we can easily distinguish between the layers. So in this layer we are converting data into segments. We are converting into data into segments in transport layer. Transport layer is responsible for the delivery of message from one process to another. Segmentation and reassembly. A message is divided into transmittable segments, with each segment containing a sequence number. So as we can see in this, we have some segments. So if we are converting a large data into a small segment, so we have the sequence number for these segments. So when we are sending the data, if our data is not going properly, like sequence wise, so we receive the requirement, like we have not received the sequence number 2, we have received only 1 and 3 data. So then we send again send the data to, then it will check this proper sequence, then only it will transfer the data into next layer. So in this layer also we check the connection control, flow control, and error control. The transport layer is also responsible for the error control. Like if we are sending a data from a transport layer, it ensures that entire message arrives and at the destination and receives by the transport layer of the receiving end, like without any damage, loss, duplication, and anything. If anything occurs, if anything got misplaced, so the receiver and transport layer requires a retransmission of the data. Now, as you can see, reliable process-to-process delivery of a message, like network layer, we are processing the data. Transport layer, process-to-process delivery, we are checking a process from one end, and we are sending a process to another end. Now we have session layers. In this session layers, as you can see, it is dividing our data into sync. We are adding some sync, and also we are adding some heading also, responsible for a dialogue control and synchronization. So as you can see in this, we have two types of communication processes, like one way at a time, half duplex and full duplex. So we all know that we all know there are three types of communication. There are three types of communication processes. First is simple duplex, half duplex, and full duplex. Simple duplex, we are sending a data only one way, like we are sending some OTPs. So we are only receiving the OTPs. We can't send a reply message to that OTP to a OTP messenger. Okay, now in a half duplex, we have the example of walkie-talkie. Like we are saying something at a one time, then at a next time, the receiver is sending some message. So this is a one way at a time. And full duplex, two ways at a time. Like best example for this is a video call as a phone call. So we are talking to each other at the same time. Then we have a synchronization. So as you can see in this diagram, this SYN, we have some synchronization. We add some synchronization bits to the session layers. In this session layer, if we are sending 2000 pages, we add some checkpoints in like after every 100 pages to ensure like 100 pages unit is received and acknowledged by the receiver end. If something crash happens, if the data got manipulated or missed, if you think about, like if the data got erased of the 523 page. So the only pages that needed to be resent after the system recovery are the pages from 501 to 523. Previous pages of the 501 need not to be resent. Then we have the presentation layer. In presentation layer, it receiving the data from the application layer, and then it is sending a data to a session layer. The presentation layer is responsible for the translation, compression, and encryption. In translation, it transmits the data. It transmits the data into different encoding system. Is responsible between the different. It is responsible for the different encoding methods. In encryption, if we are sending some information if you are carrying some important data from sender to receiver, we are sending a sensitive information. So it will encrypt the data. It will encrypt the data on this layer. Then it will send the data, and the decryption will be happen on the receiving end side. Then we have the compression. We do the compression on this layer only. So we do like data compression becomes particularly important for the large files, like very large multimedias, the audios, videos, and anything. Now we have the application layer. Application layer is directly connected to the user. From sender side, it is receiving the data from the user, and receiver side, it is sending directly to the user. The application is responsible for providing services for the user. The network virtual terminal, it allows user to log in into remote host. Then it will create a software emulation for a terminal at a remote host. Okay, then file transfer access management. This application helps the remote host to easily retrieve the file from the remote computer to use in the local computer. Then we have the mail services in this layer only. This mail provide the basis of email formatting and storage, like we are adding the proper email address, like where we are sending some data and where we are storing it. Then we have the directory service. The application provide distribution or database of the sources and access for the global information. Like for example, we have a Google Drive. We can easily sit at home and easily access any file from the global. Now, thank you so much. This is the summary of OSI model I have discussed with you. Thank you.